In this video, we're going to take a second to take one of our kinematic equations and solve it for a given variable. In this case, we're going to solve for the variable a, the acceleration. The best thing to do to start off with, circle the variable you're looking to get by itself or solve for, as well as the entire term associated with it. A term is anything that's being multiplied or divided by itself. In this case, all of the stuff in the large circle is one term. Everything over here is another term. The second one here to the left is what we need to get rid of, because everything in this bubble here is what we need to get by itself. Since these two are being added together and this over here is positive, the best way to get rid of it is to subtract it away. We want to get rid of the VI times delta t, so we're just going to subtract it away. In this case, we have VIT minus VIT. They cancel out. They go to 0. No point in writing them. However, in algebra, whatever we do to one side, we have to do to the other. Minus VI times delta t. Alright, next line down, we still have the delta x. It's still being subtracted by the VI delta t. This equal sign still floats around, and we have the 1/2 AT squared. 1/2 AT squared. Okay. Continuing along, we still want to get this a by itself. Let's do this in two steps. We still need to get rid of this 1/2 as well as the delta t squared. First, let's get rid of the 1/2. We have two ways to do this. The first thing we could do is we could divide both sides by 1/2. In this case, we have something divided by itself. That always equals 1, and this would go away. However, in the way I feel, a better way to do it is to multiply by 2. We come across the same outcome here. 1/2 times 2. Once again, this is 1. This works as well. It's algebra, so whatever we do to one side, we have to do to the other. But not only do we have to do it to the other side, we have to do it to the entire other side. We're not multiplying this 2 by the delta x. We're not multiplying this 2 by the minus VI delta t. We're multiplying it by the entire other side. Alright, so now we have the 1/2 times the 2. They've went away. On the left, we have the delta x minus VI times the delta t. And all of that is being multiplied by 2 equals a delta t squared. Alright, cool. Now, last step. Want to get the a by itself still? It's being multiplied by this delta t squared. We want to get rid of all of it, so we will just divide it away. Since they're being multiplied, the opposite function of that is division. We have delta t squared over delta t squared. These cancel out. Whatever you do to one side, you have to do to the other. Delta t squared. And I think we're ready to write our final answer. Time for some pink. We have all the stuff up here. Delta x minus VI times delta t. All of that times 2. And on the bottom we have the delta t squared. And that's everything on the left side. All that's left on the right is a. So there we have it. Taking the largest kinematic equation we have, solving it for the acceleration.